For this example, we have the summation of the quantity 1 over 3 to the power k plus the quantity 2 over 5 to the power k. We can use the property that the summation of the two terms as the two summations. So we rewrite it as summation k from 1 to infinity of 1 over 3 to the power k plus the summation k from 1 to infinity of 2 over 5 to the power k. And then consider one at a time. For the first one, the first term a, when k is 1, a is 1 over 3 to the first power or 1 over 3. And the r is the number that raised to the power k. So this case, if you rewrite it as the quantity to the power k, which is 1 over 3 to the power k, then we can identify r for the first series as 1 over 3. Yes, absolute value of 1 over 3 is less than 1, so we can find the value or the real number that this series converges. Similar way, for the second series, the first term a, where k equals 1, would be 2 over 5 to the first power or 2 over 5. And the r is the number that raised to the power k. For this series, the r is 2 over 5. That's good news because the absolute value to r is still less than 1. So both subseries converge to the real number. So, so then the summation k equals 1 to the power n of the 1 over 3 to the power k plus 2 over 5 to the power k would be the the sum of the two numbers that these two series converges using the formula a over 1 minus r and a over 1 minus r. I'm going to use a subscript as a1 r1, a2 r2. So a1 r1, a2 r2 and add them together. So for the a1, which is 1 over 3, divided by 1 minus r1, which is 1 over 3 as well, plus the a2, which is 2 over 5, divided by 1 minus r2, which is 2 over 5, and then simplify the numbers to get the first one as 1 over 3 divided by 2 over 3. So we get 1 over 2. And the second one is 2 over 5 divided by 3 over 5 to get 2 over 3. And then simplify these two fractions to get 3 plus 4, which is 7, over the common denominator 6. So this series converges to this value. Another example, we have the sigma notation or the series of 7 minus 3 to the power k divided by 4 to the power k starting from 1 to infinity. We treat similar way that what we did in the earlier example, as split this as the two summations. Since the numerator sharing the same denominator, we have the first series as 7 divided by 4 to the power k plus the series that, not plus, it's going to be minus sign, sorry. So minus the sigma notation or the series of 3 over 4 to the power k. Since 3 and 4 share the same power k starting from 1 to infinity, k starting from 1 to infinity. So to find the sum of this geometric series, we look for the sum of each series and then add them up or subtract them as what we did before. So for the first one, this one can be rewritten as 7 multiplied by 1 over 4 to the power k. Okay, so the first series, we identify the a or the first term when k equals 1 as 7 multiplied by 1 over 4 to the first power, which is 7 over 4. And the r or the concept multiple to obtain the next term would be the number that raised to the power k or 1 over 4. the absolute value of the r is less than 1. So then we can use the sum, the formula to find the sum as a over 1 minus r, which we're going to use a1 r1 notation. And for the second series, for the first term or the a, I use a2 for the second series here, equals 3 to the power 4, 3 over 4 to the first, which is 3 over 4. And the r subscript tells you about the second series, not the second term. Okay, do not misunderstand that. So the absolute value of the r is the absolute value of 3 over 4, still less than 1. So then we can also use the same formula to find the sum of the second series. So we have a2 divided by 1 minus r2. And then subtract these two to be the sum of this series. So A1 or the first series, 7 over 4 divided by 1 minus 1 over 4, subtracted by 3 over 4 divided by 1 minus 3 over 4. And simplify the numbers. The first term is 7 over 4 divided by 3 over 4, or 7 over 3, minus the second value, which is from 3 over 4 divided by 1 over 4, or 3. And simplify the numbers to be negative 2 over 3, or as a value that this theory converges to.